start from where we stopped, which is the chapter 4. Now we are going to the chapter 4 is basically on how to determine the roof slope, or what is also known as roof steepness. Yeah. There are three broad methods to determine the slope of a roof. We have three methods that are being used generally. The first one is the rise in run method, while the second one is the grease method. And the third one is a percentage method. Now we're going to start with the rise and run method. Rise and run method. So in this method, the angle or pitch of a roof is calculated by the number of inches it rises vertically for every 12 inches it extends horizontally. Rising inches here. But basically when you are on site, the carpenter, that is what they use, the artisans. So in this method, it will specify, for instance, it can be said that the pitch of the roof is 6 in 12 pitch. 6 in 12 pitch. 6 in 12 pitch. It means for the first figure that is being mentioned is for the vertical. While the second figure is for the horizontal. Do not forget, the pitch roof will be something of this nature. Here, this is the rise, while this is the run. While from here to here, is regarded as the span of the building. The span of the building. So from here to here is the rise. So when we say rise and run, that is for instance, I said example. If we are to use, if the specification says that the pitch is 6 in 12. 6 in 12. Let's say 6 inches in 12 inches. The meaning is that pitch for every arcing post, when arcing post rise by 6 inches, the corresponding run, the tie beam, will be by 12 inches. In a nutshell, 6 in 12 is just half of it. It's like 6 is by 2, 12 is half. And you know, this, when we want to, when you have our plan, we already know the span of the building. The span will be known. It is the rise, the king post I want to determine. The span will be known. Let us take for example. Okay. Let us make use of this plan. But now we have to be practical as much as possible. Because it is not a theory based alone. That is the frontage of the building. Now, what we need to do, if the specification says we are to use 6 in 12 each. Is that, and we have, what is our span here? What is our span? The span is up here. Our span is 11.25. That is the frontage. That is why this is the approach. That's why I put the arrow there. It means we have to convert this to feet first, which will give us, later give us the inches, the figure in inches. So for us to convert this into inches, you can first of all convert it to feet. And to do that, you know that 300 mm, this is 11,250 mm. So we know that 200 mm, 300 mm is approximately 300 mm is approximately 1 foot. Now, and we need 11 points, or okay, let me just simplify it further. You can even change it to meter. This will now be 0.3 meter. Is approximately what? 1 foot. And 1 foot is 18 as 12 inches. Now,
450 inches.
Now, very good. So our 11.25, to get it in feet, that will be 11.25 meters divided by what?
0.3.
So that gives us what? 37.5 feet. We need to take into consideration here that this, we need to know that this 0.5 is 0.5 of the feet,
Yes.
not 0.5 of inches.
Yes.
So which will be 37 feet. It means it will be
37 feet. 37 and a half feet.
And 6 inches.
6 inches.
You said 37 feet and 6 inches. Very good. So the meaning is that when we have, so this gives us 37. Another thing that we need to note is this. These are symbols. You need to know these symbols, okay? Inch is symbolized as this. Feet is symbolized as just this. Meter has this symbol. Millimeter has this symbol. mm. Centimeter has this symbol. cm. These are the figures we need. So which is our 11.25 meter will give us 37 feet and 6 inches. So to go 37 feet and 6, instead of writing it this way, 37 feet, we have already symbolized this as this. Okay, let's change this to inches. Now, we now inches. Now this is our span. This is our span, but we actually need the run, and the span and the run is half of the span, or we can also say the span is 2 times the run. It is half of the building from the frontage. That is where you want to start. You have to start from. So what we need there is the run, and the run is half of the span. So for us to get our run here, we are going to use what? This 37 feet 6 inches divided by 2, and that will give us what? Half of this, that will be 18 inches, 18 feet and 9 inches. Am I correct? 18 feet. 18 feet times 2 give us 36 feet. We now have 1 feet left. That will be when we divide that into 2, that will give us that 1 feet plus 6, that's 18 divided by 2, 9. Correct. Okay. So it means they are round. Therefore, round will now be 18 feet 9 inches. Now, and the specification says for our pitch is 6 to 12. So this can be reduced further by saying what ratio are they. So that will make it easier for that in ratio 1 to 2. Ratio 1 to 2. So and the 2 is going with the run. So it means half of run is what we need as our rise. If the specification says 6 inch pitch. So therefore our rise will now be half of this, that's 9 feet 4.5 inches. So this as assist us. Please with this, using rise and run method, we have been able to arrive at the right rise. We have been able to determine what the rise is expected to be for this particular design or plan. Like God's grace, we are still going to use this plan to do our first calculation. Now, let us assume that we are given the pitch to be 8 in 12. To be 8 in 12. To also be 4 in 12. We have it there. All the variations that we can have. Rise from 0.25 to 12. 0.25 to 12. Those are the standards. 0.5 to 12, 1 in 12, 2 in 12, 3 in 12, 4 in 12, 5 in 12, 6 in 12, 7 in 12, 8 up to
9, 10 in 12.
Yes, up to 20, 23, and the highest is 30 in 12.
30 in 12.
That's the highest that you can have, 13 in 12. So the simple way to determine that is to what? To look at the ratio. What ratio are these? What ratio are they? For instance, if you are to use the 4 in 12, that will be what ratio to what? 4 in 12.
4 in 12. That's 3. 1 ratio 3.
1 ratio 3. So for every, when the rise is running is increasing by 1 foot, the run will be increasing by 3. For every 1 in rise, there will be 3 in run. Okay, let's go by the examples in our material. We have 6 in we have 6.5 inch. 6.5 inches in 12 in 12 slope. So with 6.5 is 6.5 slope. Now, what we have here is to now. This is the first method that you can use. You can actually change this to slope. You can actually, when you are being given in this, it may give the artisans issue when it is not. For instance, this is just easy. let's assume you are given 8 in 4, 8 in 12, or actually 7 in 12 pitch, 7 inches to 12. So it means it might give them stress to be now calculating for every 12 inches. It will take going 7 inches. Now doing the calculation and give them actually stress them. So we can decide as a roofer, as a professional, you can decide and change it into degree. You can decide and change it into this method, degree. It has been specified this way, or you giving it to your artisans. Okay, this is what we are using. We are using 15 degrees as our pitch. That is even when they can actually get the degrees. Let us assume they specify the roof pitch in degrees. Let us assume we are asked to use 29 or 30 degrees. Specification says use 30 degrees as our pitch. So we still have to go back to our span. This 30 degrees means this has to be 30 degrees. And we want to determine our king post. Don't let us forget, it was the king post that we got here, which is the rise. So let us assume our king post, let's denote it as K. But as a matter of fact, we must have known our span, which will assist us to know or to determine our run. And if our span is what we have 11.7, okay, it's 11.25. 11.25 meter. So what will our run be? What will our run be? Just this divided by 2. So that will give us what?
5.625.
5.625. Let us assume we don't want to approximate it. Okay, 5.625. Yes. And we want to get our K. So using the knowledge of our Pythagoras theorem, we don't know our hypotenuse. This is our hypotenuse. This is our adjacent. This is the opposite. So we know the adjacent. Okay, we are looking for the opposite, big K, and we know the adjacent. So what are we using now? That is toi. That has to be toi, because we already know. So toi. So toi. So which means tan 30 degrees equals opposite over adjacent, and that will be tan 30 degrees equals, what's our opposite? K over our adjacent is 5.63. Let us approximate. So therefore, by cross multiplying, our K will equals tan 5.63 times, or yes, you can say times tan 30 degrees, and that will give us 5.63. What's tan 30 times? No. Okay. 0.57. 0.577. So times 5.63.
That's 3.25.
3.25 meters. So it means our K, therefore, our king post will be 3.25 meters. So we we have successfully used the degrees given, the angle given to get our K. Now, the third one, which is the percentage method, we'll use that now. After that, we now see how can we now, for instance, we vary by the rise in 1 year. How can we convert it into the degrees? Or how can we convert it into percentage? The percentage is easier when we are given percentage that use when it is the roof pitch is being specified in percentage. It's easier. We have to use 50% of the run. The rise should be 50% of the run. It's easier. It is easy. It is just the run times. Okay, let's do that. Example 3. Pitch 50% of 50%, yes, 50% pitch. When I give 50% pitch, still referring to 50% of the run. Okay. So it can be considered as 60%. So let us use 60% for example. Let's use 60%. So we know our run to be 5.6. Our run is 5.6. Let's approximate it 63. So 60% of this will be what? That will be, can say 5.63 times 0.6, or want to open it 5.63 times 60 over 100.
That's 3.337.
3.38 approximately meters. This is 60%. So now you can see that the three methods are not hard, but one must be able to do the right thing. For instance, if it is in inches, 6 to 12, so now one have to know how to convert from that inches to meter, except if it is specified in mm. For instance, use 150 mm in 300. So it's specified in mm already. So there's no need to convert to change the figure to fit. Now, we want to convert this. Let us assume that we are given this rise and run 6.5 inches in 12 inches slope or pitch, and we now want to convert it into slope. How do we arrive that? Do not remember this is 6.5 inches, same thing as 6.5. It's the same thing as 6.5. So we just need to divide our rise by our run. It's just to divide rise by run. So and we know our rise is 6.5 and our run is 12 inches. So 6.5 divided by 12 give us what? 6.5 divided by 12 give us what? Divided by 12.
0.54.
0.54. 0.54. 542. Okay. Good. So it's just all we need to just to find the arctan of this, which will be 0.542. The arctan of 0.542 is what?
28.46 degrees.
28.46 degrees. So we have successfully convert from the rising run to degrees. Successfully, you have been able to convert specification that was given in rising run into degrees. Let's consider this example now. Rising on to percentage this time around. Rising on to percentage. The clue of this, the first one is this. To do what we have done is to find the arctangent of the rising run, of rise over run. Find arctangent of rise divided by run. We're going to go with that. Now, we want to calculate the rising run into percentage. Example 2. Rising run to percentage. Let us assume we are given 3/8 inches. 3/8 inch in 12-inch slope. That is 3/8 in 12. Now, what we need to do now is to first of all calculate we have the 3/8, we have it in fraction. This 3/8 is pronounced as 3/8, and when we are referring to inches, don't say 3/8, you say 3/8. Is because it's 3/8 of inches. 3/8 of inches. Ideally, it's something like this. This is what is a 3/8. So it's not 3/8. That's 3/8. So for us to convert this, we are given 3/8 inch in 12-inch slope. So now for us to do this, we need to convert this fraction firstly into decimal. So that will be 3/8. 3/8. 3 divided by 8 will give us what? 0.375. 0.375. Now, what we need to do is this 0.375 divided by the 12. Now I run. We divide the 0.375 over 12 to give us 0.03125. After this will now be multiplied. This figure will now be multiplied by 100 because we are asked to convert it to percentage. So our figure, this 0.03125 now multiplied by 100.
That's 3.125.
3.125. Therefore, you can comfortably say that therefore 3/8 in 12 slope is something as 3.125 the meaning or the interpretation of this is that when we know we know the span, then the run is half of the span. So the percentage of our rise is just 3.125 of our run. That's just a percentage. So it means this will be divided by 100 times the run to give us our rise. I want to come again. What is our, as per the drawing you have been using, what is our run? We know the span to be 11.25 and the run is half of the span. And that gives us what? 5.6. Our run was of 5.625. So, and our run is now, when I want to use a run of 3.125%. So it means this percentage of this is what our run will be, our rise will be. Therefore, our rise will be equal to 5.625 times 3.125 over 100. What would that give us? We can as well say 0.0315 times this. Get our answer immediately. 5.625 times 3.125 over 100.
0.18 approximately 0.1757.
Go to 0.18 meter. It means if you can see that the range of this is very wide. This is not up to 1 inch and to 12 inches. So that is why it means our height should be 0.1, not up to 200 meters. It is 180 mm. That is what it is. So this will be in form of a kind of flat roof. Yes. Maybe a kind of flat roof.
That means the degree method is basically used for flat roof.
Not only for flat roof. Because I made mention of this what happened in one of our previous sites in Jehovah when I said the roofing company made a mistake and likes. So the architect actually gave the pitch in degrees then. He gave it in degrees. He said use so degrees. I can't really remember, maybe 28 or 23. He gave it in degrees. So it's now left for the roofer or the professional, like the builder on site, to now know how to convert it into meter. What we have done now is take from rising 1, we have successfully calculated or converted from rising 1 into the first one, okay, yes, into percentage. But the other one, okay, yes, percentage gave us this. We now still convert the percentage to our normal units, which is in meter or mm. The percentage, this is the answer of what we actually need to do here. The answer is this. This is the answer. This is the actual answer. But now, practically, that we cannot, this cannot be worked on site. In the real sense, you have to tell your artisan, your workmen, use so your king post will be this. And what your carpenter will ask when you tell him, oh, we have a job, I have a job for you. So do the car, I'll send you the drawing. Is what is the height of the king post? One of the questions you will ask is what is the height of the king post? So and it expect you to either say it in feet or in meter. So we never understand why you tell him we are using 3.10 degrees. 10 degrees. I'm not ready to work. So That was why we had to
Okay, this percentage.
I say create in 12
inches.
Now let's move further. Let's do more. Now let's now convert from percentage, from degrees to percentage. We also now do from, let's do now from degrees to percentage. We are done with this. And from degrees to percentage. Degrees to percentage. So what we need is to find the tangent of the degree value multiply by 100. So example, one year slope for the slope of 25 degrees. So what would that give us? You see, for us to convert from degrees to percentage, all we need to do is to determine the tangent of the degree. So that the specification is now in degrees. So we have been asked to find the percentage for a 25 degree slope. So the solution is to find the degree, the tangent of the degree, times 100. That is it will be tan 25 degrees. Whatever we get, times 100. That was our answer. So tan 25 will give us what? Tan 25.
0.466
0.466 times 100 will give us 46.63. Okay, let's take 46.6%. Because we are from degrees to percentage. I calculate from degrees to percentage. We have more of this in the material. Because of time, we won't be able to do much more example. So by the time we get the material, we actually can also convert from the slope in percentage to degrees. They are straightforward. Slope in percentage to degree. This is a degree to percentage. You can also reverse it. Reverse it. Now, we have some values. A table of conversion table in the material. A conversion table that has all these things we have been stressing ourselves for in. They are there. Right from 0.5 to 12 rise in 1. The equivalent degrees of it is 1.193 degrees, while the corresponding percentage figure for it in percentage is 2.08. Likewise 0.5 to 12 and the likes. For instance, if you did some, you can actually check it out now. Here is a 3/8. We don't have 3/8 there. We did one 0.5 or what? 6 in 12. 6 in 12 that we did. Yes, I'll actually get it here. 6 in 12. The equivalent degrees of that 6 in 12 is 26.57 degrees. 26.57. Why in percentage? The equivalent value for it is 50%. 50%. Now, what is the essence of all these calculations on pitch that we have been doing since? What is the essence? Are we just doing it for nothing? No. There are reasons for it. Number one, when we go through it, the middle one, we said any pitch that is above 10 degrees is regarded as pitch roof or sloping roof. But the ones that are 10 or lesser than 10 are regarded as flat roof. Number two, from this, some designs, when we see some roof, you see that this roof is too high, and as we've said earlier, that the buildability and maintainability of the roof structure is very, very important. So we have here the range that you can, where you can be, you can specify the range of the values you can specify when designing your roof, such that the roof will not be too low nor too high. So that the roof will not be too low nor too high. So it starts from this 6 in 12. That is why it is being highlighted and bolded. 6 in 12, which is 26.57 degrees. That is where the recommended pitch starts from. Not that you cannot use the upper one. Most especially when you are doing a flat roof, you can consider this 9.46 degrees or lesser, even the 2 degrees. But in the case of pitch roof that you want to come out well aesthetically, this is the minimum that will still make the structure be retain its aesthetic value. And you can also move beyond that. It can be 27, 28, 30, 30, 33 point something, and the likes. And up to the 36.87, which is 75%, which is equivalent to 9 in 12. What happened? Does that mean you cannot use figures below this? No, you can use them. But the number one, even right from the construction, the ease of construction will not be there anymore. Which is what buildability concept is all about. Also, the maintainability, when it comes to maintaining it, then you now know the resultant effect of having unnecessary height.